So we start with the next session today is about non-thermal techniques. What is used for fresh produce preservation, maintaining quality as well as safety. So of course in that course we try to cover various aspects related to post-harvest handling, reduce the post-harvest losses. So in non-thermal, probably the name indicates little bit. So we're not using high temperature, okay, not the temperature directly in that one. So that may be our outline. We're starting with the what exactly when we talk about non-thermals, and then we see some common techniques. There are many actually, so we cover some on that one. So when we talk about the food, okay, any fresh produce, it has a lot of components inside the fruits. So of course major is the water whenever we talk about the fruits and vegetable, but at the same time when we say there may be carbohydrates, proteins, some organic components as well as some minerals. So a lot of combinations, okay. So food we see it's like a complex mixture inside the food, and when we start harvesting the plant fruit from the plant, what will happen? Lot of metabolic changes happening with the food product. So it changes with the respiration, transpiration, and as well as the changes like its enzymatic activity, biosynthesis pathways. So we can say the food start to degrade the quality, okay, and sometimes some changes may be desirable, some are undesirable, like when the changes what we say sometimes ripening and things, but some is coming a disorder for the product which was not expected, or sometimes the quality degradation, some activity from the microorganisms the spoiling the products. That all activities are there actually once we harvest the product. And when we say there are chances to growing the microbes and things, what will happen with the time? It will start it or accelerate the process of deterioration. And what all other things what we all try to deal with, how to stop that or how to inactivate the process, that one. So it may, the product will remain the fresh with a good quality, because as always we talk one thing here, what consumer looking nowadays, good quality product, healthy product, and at the same time they look the product have the characteristics like fresh like products. Even sometimes in the market we get the product stored or treated with any other process, but when we eat that one, our idea is supposed to have no changes that may be we easily find that one. So the character is supposed to be fresh like product, because now we are aware that one. And when for the product's life, shelf life supposed to be extended up to certain period, because sometimes it's changes with a lot of things, sometimes for the market size, sometimes the bulk material available in the market, so we'll need to keep for that processing activities. And whenever we look for the processing, when we go for the preservation or some the value addition of the product, but the spoilage, whatever happening with the food product, that is the one reason we need to stop that one, spoilage. So that's why there are number of preservation techniques, and nowadays when we come here, when we see from the back side 20 to 30 years back what the research coming on, initially coming the thermal, the non-thermal, even the advancement is of non-thermal. So lot of techniques availability as per concern from the industry, concern from the product, we are going for that one. But whenever we're looking for the product to be preserved, and when the characteristics from the product supposed to be fresh product, so of course the industry people, even the processors, they're looking for the techniques like a non-thermal one. So as we say, when we going for the thermal one, there is a chances that heat treatment, due to heat there is a undesirable changes expected with the product. So now in the food processing, particularly whenever we see the processing side, we converting the product to another product with a different operation involving in that one. And in the food preservation side or processing side, of course we're dealing with a number of operations including chemical, mechanical or thermal operations, but with the one target here. What target we say here always? Productivity of the product and the shelf life of the product. That's the two things always we concern actually. If the product we cannot use for the human consumption or the extended shelf life, sometimes people may be not going for this one. And but at the same time there are because what we expect always for the desirable side, but we found here sometimes there are some undesirable effect also happening during the processing side. And during the food processing, one idea here, whatever organism, microorganism responsible for it is supposed to be inactive, and whatever the guidelines, standards or procedure from the market for the product we're supposed to use for this one, so we can keep the product for longer period. Now when we talk here two things in the food preservation or food processing side, thermal and non-thermal in the big categories. When coming from the thermal, is a simple one thing we always say, it involves heat. Thermals means it involves heat, actually that's application of heat, and that may be the use for the preservation by inactivating or killing microorganism enzymes which may responsible for spoilage, even the risk for the safety of the product. But what we come here, the factor, it may use sometimes a very high temperature, okay. And probably when we see the examples for that one, we may come across from starting from the pasteurization, blanching, sterilization, baking, because what is happening involved here, that's the high temperature heat treatment, okay. But what coming with the thermal one, though thermal techniques for some products is very popular, but it has bring you some undesirable changes. It may be some physiochemical, textural, even organoleptic changes that may be not be expected as a consumer, even the for the product characteristics. So we see that traditionally what the thermal processes were used, like the pasteurization or sterilization. You can see here from the starting, whenever you go to the supermarket, from the milk to your canning material, they using these treatments. But after in the thermal, there is a advancement come in the thermal treatments. Like for example, we have the radio frequency, ohmic, microwave, okay. So there are some advancement in the thermal techniques, but still just to overcome to what so traditional process we are using in the thermal processing one. So indirectly in the, for example, when you see the pasteurization, branching or baking, because we are using the high temperature at the same time for the longer period, okay. So just like when we go for the advancement, we want the heating effect, but now at the same time with a rapid process. That's what we expected here. So they using the rapid process, so at the same time the process may be rapid, and idea here to degrade it, to reduce the degradation rate from the quality process. And when we're looking for the product characteristics for the consumer side, nowadays what we mentioned here, the consumers looking the product which have desirable quality, okay. That's the repetition things what we are talking every time, every day, because it's a post harvest side. We want the product which have the specific quality I expected from particular fruits and vegetable, and at the same time the demand for the high quality, long shelf life, contain whatever nutrient components supposed to be there, and as well as good sensory qualities. Good sensory quality is the idea here for the consumers. That is the first appealing part, okay, sensory parts, because if the product have the good nutritional, good minerals composition inside, by sensory side you cannot say by the appearance or texture. That is the first appealing. We're not going to buy that one, okay. So all that things supposed to be there, and it's not for the product side, but it's like a demand from the consumers. That's awareness increasing by day by day. And then the advanced stage here from the food side, food processing side, they're looking for the technology that may be best for the consumer to meet their demand, their requirement. We come with the non-thermal processing. So one basic difference here, when we say the non-thermal, in the thermal, as we are aware, we are rely on the heat, high temperature. So in non-thermal, the process here that we're not relying in the high temperature, okay. But some process you may say temperature may be increasing, but in some process you may, but all the processes what we do here, they can use some physical, chemical or biological methods to inactivate pathogens or spoil the microorganism we are responsible for the spoilage. So to maintain product sensory as well as nutrition quality, and at the same time we always use the word here fresh like product. We not say the fresh, okay. We see always what you mention here, the product supposed to be fresh like characteristics. So these processes, when we look here, we consider there may be more energy efficient and more environmental friendly as well. And some examples nowadays which is quite popular, including cold plasma, ozone treatment, UV radiation, high pressure processing, ultrasonic, pulse electric field. So these are some examples what we consider for the non-thermal one. Now you can consider here all the processes we're not directly using or increasing the temperature during their processes, okay. So again, when we consider here the non-thermal one, because they not destroy or changes quality very less and make the fresh like character, because they are targeting with the non-covalent bond between the foods, with the molecules, okay, between molecules, whereas thermal treatment they have both covalent and non-covalent bond. So in non-thermal techniques, probably we can find here sometimes we have generating plasmas, sometimes irradiation, sometimes even the ozone, that's O3. So we consider this all the non-thermal like a mild heat treatment, okay, mild heat treatment compared to thermal techniques. So when they come with the non-thermal one, some popularity due to some characteristics or some advantages what we get from the non-thermal one, including maximum quality retention, energy efficient, very low chances or no risk for the toxic with the product. Processing time also not quite long, so we're not keeping the product for longer period. And here the processes have the high efficiency to inactivate the microorganisms which are responsible for the spoilage. So nowadays you can see in the industry side there is quite trend actually to use that non-thermal processes to keep the product safe and extend the shelf life. So as we consider here, there are number of techniques, number of methods nowadays they are using for this one, and we can see sometimes like a brief introduction for some techniques. Maybe in coming period we may go in the detailing with that all the techniques. So we can check in the brief regarding cold plasma, ozone technology, irradiation and high pressure one. So probably cold plasma, recent days, quite popular techniques in the non-thermal side, which have commonly inactivate the microorganism and pathogen which are responsible for the spoilage of the product. Okay, and mostly you can see that their uh, application is in the industry like a fresh product, processed product, even uh, cut fresh product as well. Okay, so all of the areas the cold plasma nowadays is commonly using, and at the same time the techniques what we do here, it may prevent the loss of all the or sensory characteristics as well as the nutritional one. And so particularly when we talk about the plasma, okay, before I come in this slide here, now we consider the states of matter from the solid, liquid or gases. When we supplying the energy to the solid, it coming for the liquid, from liquid to gaseous, and the fourth state of matter is our plasma. Fourth state of matter is our plasma here. Okay, so that's what we consider here. But now the plasma, what we consider mention here, plasma is more gaseous than liquid or solid, and now their properties also not similar like gas, liquid or solid, and that plasma we can use for inactivate the microorganism. So we coming on the step actually how we working this way. So once we generated the plasma from the for the inactivate the microorganism for the product, so in the plasma, first one is our the plasma have the chemical interaction. What is the plasma have some radicals, reactive species and charged particle which may interact with the cell membrane of the product here, and due to UV it may causes the cell damage to the cell membrane. Okay, and whatever the internal cellular components of the product. But after that one, what will happen once the after the DNA, the main DNA broken down during the recombination of the plasma, but now the microorganisms are not active one, they are inactive, activated there during the process. So this process commonly used as sometimes inactive microorganism, but mostly process you can say like a sanitary process. Okay, just like a cleaning surfaces, cleaning product. Okay, from the surface cleaning one. So that is used mainly for the fruits and vegetable industry, from the surface cleaning, surface sanitation one. And now in the plasma generation, maybe we can go in the detail in the class. There are number of options with the cold plasma generators actually, and even sometimes they use it the vacuum or lower pressure, depends on the product, what product we want to use to inactivate this one. So when there is a number of cold plasma application and techniques which may depends on the what type of product we are using, the surface properties of the product. Okay, are you using for the processed one, fresh one, as well as cut slice product. Like for example, when we talk about the one type of plasma where they working in the low pressure or vacuum, we cannot use that one for the high moisture product, because in the low pressure what will happen, it may be give a undesirable effect like a shrinkage on the product. Okay, and due to high moisture one. So even though based on that one we can select what type of plasma methods we are supposed to use here. Then what is the initial microbial load, because after this one, because you may be select your intensity, what intensity you need to use, what time you need to keep the product inside the chamber for the inactivation. So that parameters commonly they use and select when they started the process for the cold plasma one. So mostly studies you can see here, because we tried sometimes with the fresh cut product, but the cut product industry still is quite challenging. Okay, so just to showing here some products. There was a kiwi actually. They are the sliced kiwi, and they are the control one and the treated one. And the characteristics what we found here, the product what the kiwi slices one after 4 days treated with the cold plasma, still like a fresh like characteristics. Even for the strawberry. Now what we come here with the strawberry here, if you see that we try to make the minutes here from 0 to 20, depends on the how much time is the processing time for the cold plasma we are using, and what may be our intensity. Even that also affects the quality of the product. Okay. So in the coming sessions, we may check in the cold plasma in the more detailing also. Then another technology in the non-thermal, it is ozone technology. Okay. So as we aware, we have oxygen like O2, and ozone means we have one more. Okay, it's O3 like a trimatic oxygen molecules. And why it using? Because it has very high oxidation reduction potential actually when it's O3. Now the process still very popular nowadays, because I believe around mid 20th century it is ozone come in the market. Okay, to preservation the food product. And the basic purpose here of ozone to extend the shelf life of the product, and that is commonly used. Now we have 3 oxygen molecule, O3. Out of that, one O, which is quite unstable, okay, without bond, and when it decomposes, it develops radicals like water, hydrogen, carbon dioxide, and with maybe interact with the interaction here to inactivate the microorganisms. So when we come here in the process, actually we have the O2 and third bond what we say here, which is the quite weaker one. Okay, the big bond like O, which combines with the organic or inorganic molecules from the material or the food material to destroy them through the oxidation process. And then after the process, it may be revert back to making the O3 again, and that's why we consider it's quite environmental friendly process even. So during the production side, that O2 what we mentioned here, to break it in the singlet oxygen, and it becomes from O2 to O3, that's the ozone one. So even the ozone treatment, sometimes it's used as a disinfect the processing one. Even that there was sometimes we say they make the disinfected water, ozonized water for the treatment for the products. So they may use in the form of liquid as well as the gaseous one for the all fruits and vegetable category. So when we look for the ozone, the benefit here actually, now you can come here, heat treatment not involved in the process. Okay, heat treatment not involved in the process. And okay, making one thing here, how we getting the ozone, and the ozone process as very effective for the all keeping the product's quality, because mostly as the processing not involve any heat treatment or something, including the firmness, weight loss, or even the shelf life, that is the achieved actually. Whatever the study we see with the ozone treatment, that is maintained when we are compared with the other product qualities. And even it will inactivate or reduce the activity of enzymes which may be responsible for the product spoilage. So what will happen here, the process where the product may get soft, actually the process may be reduced or stop here, so preserved for the longer period. And nowadays in the horticulture product, particularly fresh fruits and vegetable, it is also quite popular nowadays. Even India, there are the industries, particularly fruits and vegetable industry, they are applying the ozone treatment for the products. Okay, then we will come with the third one, that's the irradiation technology. Okay, particularly when you say the electromagnetic spectrum, and we talk here the irradiation from this area, from the X-ray, gamma rays that may use for the treating the product. Now you can aware this one. Still the technology commonly will not available everywhere, because mostly from the bark from the Mumbai. If we like to use this one, they are the one who is helping here to use the technology. Okay, so we using X-ray gamma rays for this process. Okay, sorry. So one thing here, when we say the irradiation or radiation, so the product, when we radiate the radiation, and that is absorbed by the product. Okay, that's what we get the irradiated food. Okay, and the food irradiation also we consider here our non-thermal process. Okay, and okay, non-thermal process. So mostly if you see the irradiation, that may be, it may use for the product to depict the depicted product to sorting separately, control pathogenic microorganism, evidence enhance the bioactive components, and even the sprouting and things for the products, particularly like potato or onions, they may be controlled with this irradiation process. Now this process commonly used for directly to inactivate or kill the organism, microorganism, insect or parasite, which may looking to the preservation effect. Now, as I mentioned before, that's we are using the radiation like a gamma, X-ray or electron beams for the irradiation process. And for this one, for gamma radiation, we may get from the cobalt 60, okay, which emits the radiation, Then the accelerated electron, what we're using here, that's the electronic beam up to 10 and X-ray energy is supposed to be just 5. Now if you read about the irradiation, we can think they give us a doses actually irradiation. That is quite important here, because with the safety for the purpose and even for the human consumption, there are some guidelines. We cannot go beyond that much doses for this one. Okay, so they give the doses by the name of radiation absorbed dose, that's we call it a rad. Okay, and what they consider here, one rad is equal to 100 erg per gram, that is absorbed by the product, and 1 rad is equal to 100 kilo rad. But mostly some microorganism quite active, they not inactivate with that low doses. Okay, low doses. So this one come to maximum time, you can say the doses what they use in the kilogram. So 100 rad is equal to 1 gray, and 100 kilo rad is equal to 1 kilogram. So whatever you are reading nowadays actually, so the radiation we using for this one in the kilogram. So they again categorize this one according to what type of doses we are giving to the product. It may be low, medium, or high dose. Like low dose up to 1 kilogram, that is mostly used for to prevent the sprouting. Okay, reduce the ripening process and extend the shelf life. Commonly, the facility what we have in India here, they have some facility near Mumbai. Okay, and they what the product they commonly use the sprouting. When we look here, whenever they go for the market, like onions, because that has the issue of the sprouting. Even the potato, if we keep for the normal condition, you found a sprouting there. Or the process like a mango, when we selling for the market, the idea here to reduce that ripening process or slow down the ripening process when they going for the exporting. So the low dose up to 1 kilogram, that is commonly used here. Then like a 1 to 10, that is like a medium dose, like a pasteurization, that is eliminating or some pathogens, that is foodborne pathogens, or indirectly helping here to reduce the food spoilage. So it has a higher dose and working similar way like a pasteurization. So that's why even that dose they coming like a pasteurization. So you not consider that the heat treatment is going with the like a pasteurization, just a purpose here. And third one is like a sterilization, where they have higher dose. Okay. So they may like a sterilized product, killing microorganisms which are responsible for the spoiling the product and keeping the product for longer period. But now with the irradiation, there are some guidelines with the countries actually. Okay, some countries have the guidelines, so even they may not allow going for the higher doses for the product. So they need to look for the guidelines. But now in the research side, they're looking for that one even going more than 50. So if they working with a higher dose, how the characteristics of the product changes, and even what will be is application side towards the human. Okay, that may be also important one, because at the end whatever fruits and vegetables we are dealing with indirectly going to the human consumption. So if you read this one, even the doses, sometimes you found here some country guideline was quite strict on this one. And mostly in the irradiation, one thing actually we look here to keep the maintain the product. So like we consider it a single DNA product, single molecule product. If the consider irradiation directly attack on that one and that targeting molecule, but in reality it's not. Okay, so if the assumption is that it's a single molecule to directly attacking this one, but mostly cases they need to consider the second option, that's the indirect one. So they directly what they consider like mostly fruits and vegetables, they are the water. Okay, they are the water, and so they consider here firstly with the reduce the water, and then even the outside the cell, attacking the cell. So mostly that's the like assumption for this one, actually, not to go with a single. Whenever you come with the irradiation, we never consider that a food product like a single cell component. So this process is still using and quite popular. There is some probably in the research side you not found many studies or many researches going on outside, because for this one I believe in India you need to get the permission from the bar to use this one irradiation. They only one who is helping you to set up your setup and things for this one and do the study. So mostly is they have the setup in near Mumbai, actually I think 3-4 manufacturer, but they like to increase this one because there is a huge potential for the market for the fruits and vegetable, particularly the sprouting, getting the sprouting or dealing the ripening the process. Then we come with the fourth process, that's like a high pressure processing. Sometimes we have the different name, actually, high pressure, hydrostatic pressure. Okay, so now this process quite rely on how we applying the pressure. Now the pressure you can consider here 100 to 1000 megapascal. Okay, it's a huge pressure. You compare this one like in our car vehicle we not go more than 30 megapascal. 30, that may be the limit, actually 25 to 30 we keep. Now it go up to 1000. So mostly in the food industry the optimum we consider around 600. Okay, that's the optimum for the most foods and vegetable processing industry they keep in the high pressure one. So this was a kind of pasteurization process, but not rely on the heat but rely on the pressure. But as we mentioned here, it may increase the temperature, but how? When we go 100 megapascal pressure increasing, so it may increase around 3 degrees Celsius temperature. So even you go up to the 1000, it may be still with your 25-30 degrees Celsius. It's not go more than that one. So it has the some benefits like enhancing the food quality characteristics and maintain this one, because if you see the process here, sometimes there is a desirable changes we can occurring towards the product quality. So when we see in the high pressure one, they basically work in the 3 basic principles, that's isostatic, Lee Chandler, and some microscopic reordering. So in the isostatic, what we consider here, the product what we have, we applying the pressure from the all side, like a uniform pressure applying to the product. So if the product is here and uniform and homogeneous, so every particle we consider here the treating same way. Then second one, with the Lee Chandler principle, what we say, when we applying the pressure, there is a chances what we the changes in the volume of the product. Okay, and as soon as we release the pressure, it may come back to their original one. So one thing probably you may come here, sometimes we can use the product we not keep the directly. Okay, it may be how there's some container, it may be how some films, some package, some gas, that way they can use here. Direct product we cannot have the properties, it may change or completely destroy. And the liquid commonly used in the high pressure processing is a water. It's a water. And even in high pressure, when we say the microscopic reordering, this one killing the microorganism, as we keeping the temperature and increasing the pressure, there is a increment of 3 degrees Celsius whenever we increasing by the 100 megapascal pressure. And in this process, when pressure is increasing, it will helping here ordering the molecules. And so the pressure and the temperature in this process, they work in opposite way actually. That's why we call it antagonistic process, and changes their molecular structure and inactivate the microorganisms. And one thing again, you can see here in the package, nowadays we get the package material actually. So when we selecting the package for the high pressure processing, we need to make sure that they have the properties, the change in volume up to 15%. Okay, so if that, we cannot use every type of film, every type of package for the high pressure processing. Mostly you can see in the tin, water, glasses they can use, but the films, what we said, it's supposed to have the properties, it may be reduce its volume by the 50%. When we applying the pressure, we can see our second principle, there is a change in volume of the package itself even. Of course, after releasing the pressure, it may come back to this original shape. So those who working in the packaging side, maybe you can consider this part as well here. Okay. Then when we look for the inactivation, because that's another role whenever we talk about the shelf life, extend the shelf life of the product, means killing the microorganism or inactivate the microorganism. So just to seeing this one, okay, the microorganism active when we applying the pressure. So after this one, what will happen here, the microorganism, as soon as we started applying the pressure up to a certain level, it gets the disturb the membrane due to shear forces generated due to our high pressure, applying the high pressure. So what will happen here, it may disturb into their cellular functions of the product, and then the thermal damage and protein deformation all happening during the process. And yes, the pressure applying from the all sides, so equal and uniform side, and this process will happening, and as soon as we release the pressure, what will happen, it comes to original shape. But the thing what will happen now, the activity of the microbes, activity is not what we say the functional one, so it was stopped or ceased during the process, so they are not active. So that's why we mentioned here they are physiologically inactive, and that's why after the process we can see here this. So it is helping to extend the shelf life of the product. So mostly cases, as we mentioned here, as we go up to 1000 megapascal, so this may be some optimum range, you can see here maximum pressure, but the people are doing the research studies. So what may be optimum condition for different products, if they going for different packaging material, what may be the best suitable pressure. So just to see here the schematic sketch actually when they coming with. So one thing what we see here in the high pressure processing, there is no change in the product shape or size. As soon as we release the pressure, it will come back to this original shape or size. So mostly the high pressure one, when we say the high pressure container, pressure vessel, we have the product, and this may product we have the different packages. Okay, different packages. So number of packaging side we can use here. Okay, but as mentioned, liquid commonly what we use is water for this one, applying the pressure this one. So we cannot keep the product directly. So the high pressure processing is not only the fruits and vegetable, then you can found is applied towards the meat industry, meat, fish industry, on the processed product as well. Then once we loading the product, applying the means filling with the chamber with the water, and then whatever the or optimum pressure we like to use for this one, like pressurizing the process, and then we keep for the certain period as we require for the particular product to inactivate the microorganism which is responsible, and then unloading the pressure from and release the product from this one. The process looks but is like require high pressure, means the environment need to be checked carefully, because you consider the pressure is huge. Actually it may be disturb whole building if it's something happening in this site. So it may do is going from 100 to 1000 megapascal, and this is the changes what we're looking for, the how to inactivate microorganism, enzymes and other agent which is responsible the spoilage, but the target here without increasing the temperature. So in the whole case actually temperature just increasing, that's the number 100 megapascal, 3 degree higher temperature. So the process come here, and quite popular is the canned and packed product nowadays. Actually in industry whenever we see is canned and packed product, these processes are quite popular because it comes with the desirable output, maintain the quality for the longer period. And even so in the this process, even the other operations we may come consider, like the that may be steps particularly it may come in the package. So all the pre-processing operation we can do with this one, before this one actually. So the factors when we look here, actually what we're targeting how for the product, and depends on the time. When we say the loading time, the pressure time, it completely depends on the what type of product we are looking to process with the high pressure processing. And the particularly changes what we look here, that may be desirable one, looking from the texture, structure, particularly for the some meat process, they may found the desirable changes in that product one. And the process, and so the processing time, it may also vary from the product to product. So this type of pasteurizing process, because it has a uniform, because when we look for the product actually are you dealing with the number of operations. With high pressure one, each components of the part these were equally treated with the high pressure one. So it may have quite benefits, and particularly all the industries even looking for the ready to eat product, ready meals, juices, milk, or dairy industry, fish or meat industry, which may even the raw as well as the processed product. Okay, raw as well as processed product, quite popular this process. So this about our processing non-thermal one. So coming sessions maybe we can go in the technology detail in like ozone or irradiation or cold plasma in detailing on this one. So we stop with this process now here with the non-thermal process one, which may be quite popular and still in industry looking some options which may be more advancement with the specific commodities actually. So now will ask you for the your queries, questions, which may be, yes please.
Hello.
Yeah.
So if it is a non-thermal process, so and if the temperature is increasing, so how it is becoming a non-thermal process?
Okay. So actually what we consider here in the process, probably I mentioned one part here starting like mild heat treatments here. Okay, so now the temperature we can come here, we're not going more than ambient temperature, like okay, like for example if you're processing at 0 and every 100 megapascal your temperature increases by 3 degrees Celsius, not more than 3 degrees Celsius. So even you go for 600, So your temperature less than 20 degrees Celsius. Also, it's like a mild treatment, mild heat treatment.
And another question, when you have told that the about the indirect treatment of the irradiation, like
Yeah.
the UV, because I know that if direct treatment is given, which you have also mentioned that it could damage the DNA.
Yeah.
So, can you elaborate about the indirect treatment?
Like when we consider it, because the components of the just me come on the slides. This one, you have to, that's I same one or
Yes, yes, yes,
yes.
yes. This one.
Okay. So like mostly the food components, what we consider, they have the water molecule, water. Okay. So using the irradiation, what we consider, we are radiolyze the water first with the irradiation, and then considering they are separate actually, and the cell or the DNA we can consider from the outside the water molecule. So it's like we not consider like we are heating the one cell completely. We are processing okay for the regular for water separately and DNA. Then combinedly it may come together.
So, how long the effect of this radiation in water remains?
No, same. It's like because it process maybe same time actually. It's not a separately.
All right.
Oh, in
all
the,
right.
means it's not like a separate process we are doing. We are doing the same one.
All right. All right. Thank you.
Even we have the irradiation in the, we can have the detailing station on that one where we may
All
process
right.
this one
Thank you.
completely.